Hello everyone. Have you ever tried to find the shortest route on Google Maps or wondered how a computer solves a maze? Behind the scenes, it is all about how we explore connections, and that is where graph traversal comes into picture. Today, we are going to see BFS traversal. So, graph traversal refers to the process of visiting all the vertices in uh, in the graph in a systematic way. It is how we search, explore, or analyze the graphs. There are two powerful traversal techniques. One is breadth first search, and the other is depth first search. Now, in breadth first search, it starts at a given node, explore all its immediate neighbors first, then their neighbors, and so on, like a ripples in a water. Thus, it explores a graph level by level. To keep track of what to explore next, BFS uses a queue data structure which works on first in, first out principle. It also keeps a record of visited nodes to avoid going in a circle. Uh, In the algorithm, it first starts from any arbitrary node in the given graph. Then we can enqueue that starting node. Then, while the queue is not empty, dequeue a node from the front of the queue. Then enqueue all the adjacent nodes of the queued nodes that have not been visited yet and repeat the process. Okay. So in this particular thing, note that the adjacent vertices can be enqueued in any order. That is why there is no unique output or no unique order. The order depends on the sequence in which the vertices are enqueued. Here in this particular example, first we will start exploring the node from the vertex A. So vertex A is enqueued first. We will mark it as a visited one. Okay. If the node is visited, it is set to 1. Otherwise, it is set to 0. So initially, we have initialized or set the visited array for all the vertices to 0. As and when we are enqueuing it in the queue, we are marking it as visited one. After that, we will dequeue as per our algorithm. We will dequeue that particular node, okay, and we will print it. After that, we will check all the adjacent vertices of the dequeued element. The adjacent vertex of the A is B, and that is not yet visited. So that is enqueued in the queue. And the second is D. Okay. Now, after that, and the third adjacent vertex of the vertex A is E. Okay. Now, after this, we will set these vertices as visited one. Now, after this, we will dequeue the node B and we will display it. So node A is displayed, node B is displayed. After that, we will check all the adjacent vertices which are not yet visited and enqueue them in the queue. So there is only vertex C which is not yet visited. So that vertex C is enqueued in the queue. After this, the next task is dequeue the element, print it, then enqueue all the adjacent vertices of node D. So adjacent vertices of node D which are not yet visited is only one vertex, that is the vertex G. So mark it as visited one and enqueue it in the queue. So vertex G is enqueued in the queue. After this, we will dequeue the element E and display it, and we will enqueue all the adjacent vertices of the vertex E. So all the adjacent vertices of the vertex E are already visited. So there is nothing to enqueue. Now then we will repeat the same process. Dequeue the next element, that is C, display it, and after that we will enqueue all the vertices of adjacent vertices of the node C which are not yet visited. So there is only one vertex that is not visited, and that is nothing but the vertex F. Okay. Then repeat the same process. Dequeue the vertex G, display it, and enqueue all the adjacent vertices of vertex G which are not yet visited, and there is only one vertex, that is vertex H. Mark it as visited one. After that, again repeat the same process. Dequeue the element F, check all the adjacent vertices of the vertex F. So all are already visited one, and then dequeue the next element. Okay, so after dequeuing, display it and check all its adjacent vertices. Only the adjacent vertex that is not yet visited is vertex I. So enqueue it in the queue. Okay, and repeat the process. So dequeue that. Okay, so after dequeuing, we will display and check its adjacent. There is nothing remaining, and as well as there is nothing in the queue. So stop the process. So whatever is this ordering, this particular ordering is one of the output. The other, as I told you, the output or the sequence, it depends on how you are inserting the element, the order in which you are inserting the element. Okay. Now, then the next thing is applications of the BFS. So BFS traversal can be useful in many real life applications. Some of them are finding the shortest path in unweighted graph like maps or a maze, then social network suggestion, finding the closest friend connection. Then the third application is web crawler for exploring the sites level by level, and the last application is AI pathfinding in the games. Thank you.